We will explore various components essential for electrical installations, their functions, and applications. First up, we have the service entrance cap. This component is essential for any building that receives overhead power or telephone lines. It serves as a weatherproof entry point where these wires transition into the structure. Often referred to as a weatherhead or gooseneck, the service entrance cap is designed to protect the entry point from rain, snow, and other environmental factors. Its importance is that without a proper service entrance cap, moisture could enter the building, leading to potential electrical failures or hazards. It ensures that the wiring remains dry and functional, which is critical for maintaining a safe electrical system. Installation considerations. When installing a service entrance cap, it's important to ensure that it is securely fastened and positioned correctly to allow for proper drainage. This prevents water accumulation, which could lead to corrosion or short circuits. Next, let's talk about electrical enclosures. These are protective cabinets or boxes designed to house electrical or electronic equipment. They play a vital role in safeguarding sensitive components from physical damage and environmental factors. Electrical enclosures are typically made from rigid plastics or metals such as steel, stainless steel, or aluminum. The choice of material often depends on the environment in which the enclosure will be used. For instance, stainless steel is preferred in corrosive environments due to its resistance to rust. Besides protecting against electrical shock, enclosures also help in organizing wiring and preventing accidental contact with live parts. They can be equipped with locks for added security, ensuring that only authorized personnel have access to the electrical components inside. Moving on to the convenience outlet, this device serves as a readily accessible source of electrical energy for various appliances. Types. Convenience outlets can be single, duplex, or triplex, depending on the number of devices they can accommodate. They can also be classified as flush type, which is mounted directly into the wall, or source type, which may be part of an extension cord. Usage. These outlets are typically fastened to walls in homes, offices, and commercial spaces, providing a convenient point for plugging in devices like lamps, computers, and kitchen appliances. The design and placement of outlets are crucial for ensuring that they are easily accessible while maintaining safety standards. Now, let's discuss the male plug and lamp holders. Male plug. This device is essential for conducting electric current from the outlet to the appliance. It features prongs that fit into the outlet, allowing electricity to flow. The design of the male plug is standardized to ensure compatibility with various outlets. Lamp holder sockets. These components hold and protect the lamp, ensuring it remains securely in place while allowing for easy replacement. Lamp holders come in various designs, including flush, hanging, and surface types, catering to different lighting needs. Safety considerations. It's important to ensure that both the male plug and lamp holders are rated for the appropriate voltage and current to prevent overheating and potential fire hazards. Next, we have switches. These devices are crucial for controlling the flow of electric current in a circuit. Functionality. Switches allow users to easily turn lights and appliances on and off, providing convenience and energy savings. They can be found in various shapes and designs, including toggle switches, rocker switches, and dimmer switches. Types. They are classified as hanging, flush, or surface types based on their installation method. For example, flush switches are embedded into the wall, while surface switches are mounted on top of the wall surface. Installation tips. When installing switches, it's essential to ensure that they are properly rated for the electrical load they will control. Additionally, switches should be installed at a height that is easily accessible for users. Let's move on to circuit protection devices, which are vital for safeguarding electrical systems. Fuse. A fuse is a circuit protective device that automatically blows to cut the current when an overload or short circuit occurs. It acts as a sacrificial device, breaking the circuit to prevent damage to wiring and appliances. Circuit breaker. Similar to a fuse, a circuit breaker automatically trips to cut the current during faults. However, unlike fuses, circuit breakers can be reset after tripping, making them more convenient for ongoing use. Importance of protection. Both fuses and circuit breakers are essential for preventing electrical fires and equipment damage. Regular testing and maintenance of these devices are crucial to ensuring they function correctly when needed. Now, let's look at junction and utility boxes. Junction box. This octagonal-shaped enclosure is where wire connections are made. It provides a safe space for splicing wires and is often used to house connections for lighting fixtures. Junction boxes can be made from plastic or metal, depending on the application. Utility box. A utility box is typically rectangular and is used to house flush-type convenience outlets and switches. It provides a neat and organized way to manage electrical connections. Installation considerations. Proper installation of junction and utility boxes is crucial for safety. They should be securely mounted and accessible for future maintenance or inspections. Next, we have electrical wires and cords. Flat cord. This type of cord is commonly used in extension cords and temporary wiring installations. It is available in various gauges, with gauge number 18 and gauge number 16 being the most common for household use. Stranded versus solid wire. Stranded wire is made of multiple strands twisted together, providing flexibility and ease of installation. Solid wire, on the other hand, consists of a single strand and is typically used for permanent wiring installations within buildings. Safety tips. When selecting wires and cords, it's important to choose the appropriate gauge for the application to prevent overheating and ensure safe operation. Let's discuss tapes and conduits. Rubber tapes. These are designed for splicing and terminating wires, providing moisture protection and padding. They are rated for high-voltage applications, making them ideal for various electrical tasks. Electrical tape. This pressure-sensitive tape is used to insulate electrical wires, preventing accidental contact and short circuits. It is available in various colors, which can be used for coding and identification. Electrical conduits. These are protective passages for electrical wires, ensuring they are insulated and protected from physical damage. Conduits come in various types, including rigid metallic, flexible metallic, and non-metallic options, each suited for different applications. There are several types of electrical conduits, each with unique properties and applications. Rigid metal conduit, or RMC. This is one of the most commonly used conduits in commercial settings. RMCs are made from coated stainless steel or aluminum, providing excellent protection against impacts and corrosion. Electrical metallic tubing, or EMT. Often referred to as thin walls, EMTs are lightweight and easy to bend, making them ideal for indoor applications where flexibility is needed. EMT is usually made from galvanized steel, which provides excellent corrosion resistance. Some EMT can also be made from aluminum, which is lighter and also resistant to corrosion. Flexible metallic conduit, or FMC. Commonly known as greenfield, FMCs are made from spirally wound metal strips and are used for the last few feet of wiring where conventional conduit systems are difficult to maneuver. Rigid steel conduit, RSC, is a type of conduit made from heavy-gauge galvanized steel. It is designed to provide robust protection for electrical wiring in various applications. Here are some key features of rigid steel conduit. Material. Made from heavy-gauge galvanized steel, RSC offers excellent resistance to corrosion and physical damage. Strength. RSC is known for its strength and durability, making it suitable for environments where wiring may be exposed to mechanical stress. Polyvinyl chloride, or PVC conduit. These are affordable and flame retardant, making them suitable for various applications. However, they should not be used in hazardous locations or where they may be exposed to high temperatures. Finally, let's explore electrical fittings. Conduit bodies. These tubular units connect conduits and provide access to the wires inside. They come in various designs, allowing for straight connections, 90-degree bends, and transitions between different conduit types. Bends and couplings. Bends allow for changes in the direction of conduits, while couplings securely link lengths of conduit together. These fittings are essential for creating a safe and efficient conduit system. Bushings and lock nuts. Bushings create a smooth entry point for conductors, protecting them from damage during installation. Lock nuts secure the fittings in place, ensuring a stable and safe connection. Straight connectors. Straight connectors are fittings designed to join two sections of conduit in a straight line. They provide a secure and reliable connection, allowing for the seamless routing of electrical wiring. How straight connectors are used in various applications. It is used to connect conduits to utility boxes, square boxes, enclosures, and junction boxes. In conclusion, understanding electrical materials is vital for safe and effective electrical installations. Each component plays a crucial role in ensuring the reliability and safety of electrical systems. Thank you for joining this discussion. If you have any questions or would like to delve deeper into any specific component, feel free to ask in the comment section. And please subscribe to Electrifying Insights for more.